Hello YouTubers, this channel is all about RV living, traveling, and do-it-yourself projects. Please hit the subscribe button below. Now this is the inlet for your shore power. It's mounted here on the outside. It is a 30 amp plug. This 30 amp comes in to the RV and goes to a breaker box, and that breaker box has two 20 amp breakers in it. The first breaker goes directly to my overhead air conditioning, so the air conditioning is not powered in any way by this inverter. I rarely use it, but if I'm in an RV park and I want to plug in, I'll turn that breaker on and it will power the overhead air conditioning system. The next breaker is the breaker that goes to the inverter. And so whenever you plug in and that breaker's on, it powers up the inverter, and the inverter switches from the battery bank to the shore power, and it feeds to my breaker box. So what's important here is before you finish your installation and you start putting your build together, it's very critical that you do your rough wiring. And if you are going to do shore power, before you put your insulation in, you should cut the hole and mount your shore plug like I just showed you on your RV, and just run some wire in to wherever your main breaker box is, and that box would be considered my main breaker box. Just like on the outside of your house, you have a main cutoff, and then it goes into your breaker box that feeds all the breakers for your house. Now, before I go up front and show you my fuse breaker box, we'll just go over some other things that's in the back of this RV. So the power comes in from the shore, it goes to the inverter. Out of the inverter, if it's using shore power or battery bank power, it leaves the inverter, and it runs up to my where my fuse panel is. So it's critical that whenever you're building out your RV, you have this all planned out so you can rough wire to these locations. So you would want to rough wire from where your fuse panel is to your inverter. My inverter is a place I can get to it very simple. Most RVs, they'll be underneath a cushion seat or underneath a kitchen sink. I've seen them put in all kinds of different places, but they're typically not that easy to get to, so you got to do the rough wiring. And if you're going to feed anything directly from your shore power that's not going to go through your inverter, you'll need to run wire from the breaker box to those appliances as well. But once you get to the inverter, then you need to run a cable, and I've run them overhead here over my refrigerator, and it goes up to my fuse panel. So there's a 10 gauge wire that leaves the inverter, and it's not very long, and I'll show you from a different view that where it runs to, and it will feed the whole fuse panel. Now, my breaker box inside is a DC fuse panel and an AC fuse panel, so I feed the fuse panel inside from the inverter. And since this is a 24 volt system, I also convert directly from the battery. You'll see that little silver box mounted up there. That is a converter. It converts 24 volt to 12 volt, and it does not go through the inverter. In fact, the refrigerator, as you see, I use it as a freezer. I don't really use this as a refrigerator. See if I can focus in on here. And currently I'm showing 28.5 volts, and the temperature inside the freezer, and it's running right now. I'm not sure if you'll be able to hear it because it's very quiet. It's got 29 degrees. I have it set for 28, and I also have the shut off set or 25 volts. So if the battery bank is below 25 volts, the refrigerator will shut off always. Now, if you'll notice down here at the bottom, where the plug is in, there's also an AC plug. This refrigerator I could plug in always to AC and always to the battery bank, and if I'm on shore power, it would automatically switch to the shore power. I don't ever use that. This refrigerator runs all the time off of this battery, and as you see, I've never have charged these two batteries only with the solar. The solar is on right now. You notice that the little green light is blinking. So for the solar, it comes in from the top and it comes down to this breaker right here. This is also my shutoff for my solar, so I can isolate the battery. You'll notice in here, and I'm going to change this for this other battery, but there's a 100 amp breaker here, and when I trip it, that isolates the battery. So the battery is, notice the refrigerator just shut off. Now this is a paralleling switch. If I were to put two batteries in here, I have an option to run off just one of the batteries, run off the other battery, or I can run off of both in parallel. I'm not sure if I'm going to put the switch back in, but I will not get rid of it, because eventually I'll probably build another battery and mount it right on top of the battery I've just built, so I'll have 10 kilowatts rather than just 5. And if I do that, they will both be two separate 24 volt batteries. I'll have this switch to combine them. This is a marine combining switch. Use them in boats a lot. Most boats, if you're running offshore, you'll have two batteries, and you'll have this set to one, and then you got a backup battery. You get ready to start your engines, and they won't start. You can switch over to the other battery, or you can combine the two batteries for more power to start your engines. And underneath here, I mean, you won't be able to see inside here, is the inverter. And I'm going to pull all this out of here to redo this for this other battery. But like I said, I'm showing you the back of this. So what I recommend before you do your electrical, to do a rough sketch where everything's going to be located, what type of refrigerator you have. Now this refrigerator is in a drawer. It pulls out on the other side, and it's on, that whole box there is on rollers, and it rolls. There's 8 steel 1-inch rollers underneath there mounted that it rolls on. That is good, but it's also bad for the fact that you got to lock that thing down, because I've forgotten to lock it down one time and I had to stop real quick, and that sucker will roll on you. So that's pretty much the rough wiring back here. The main thing about rough wiring is you got to know where your fuse panel is going to be inside, and that is the critical thing. And next we'll go up front and we'll take a look at that. So this fuse panel here inside the living quarters of the RV, it is a AC/DC fuse panel. And all of your loads, your rough wiring, will run from here to all of your outlets or your appliances. The only power that comes to this fuse panel is off your inverter, and I have mine as a 10 gauge wire that's supplying the AC side of this. And then I've got number 8 wire running from my converter, number 6 wire running from my converter to the 12 volt side of this fuse panel. So those are the only 2 wires running to the panel. But from this panel, I've got 4 breakers in it that supply outlets in the kitchen area, the air condition area. I have an outlet that goes to the back, and I have another outlet that goes up to the front overhead of the RV. So you need to know where this fuse panel is in order to do your rough wiring, because all your wiring is going to be in your walls before you insulate. So again, it's critical you get a SketchUp program or a 3D program. You draw out how you're going to build out the RV, and then before you start, Any holes in the outside of the vehicle, you need to drill and mount your 30 amp shore power plug, and to save you a big hassle, because if you insulate and panel the walls and you say, oops, I got to go drill a hole, and you got to take everything apart to get into those walls to run your rough wiring. So that's how you wire an RV. Check you later.